This is Josh White from JW Math Tutoring. In today's video, I'm going to go over 10 problems from the June 2025 Digital SAT Math Test. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I start going through the 10 problems on this June 2025 SAT official exam worksheet, I just want to mention a couple things like I do at the start of all these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, I have compiled these problems mostly from Reddit, some from Discord, but they may look slightly different than question you have seen if you took the official June exam. So I've tried my best to, I think, make them, realistic and represent what the questions were asking. But there could be some minor differences between what you saw in the exam versus the question you see here. And the other thing to keep in mind is some of these on an official exam might be multiple choice, but I'm doing them here as free response. So it's possible there are additional solution methods available if the question is set up with multiple choice answers as compared to a free response type, where you have to type in the answer. Third thing, there will be a link in the description of the video and in the pinned comment to this worksheet, so you can go ahead and download a copy of it, try to work through it first. And lastly, also check out the videos to worksheet number 1 and then also worksheets number 3 and 4 once those are posted. Alright, so let's go ahead now and get started with question number 1 on this, again, June 2025 worksheet number 2. So here you have an equation. It's actually a quadratic equation. It has a constant in it, and we're asked to find the maximum value of 4k. So first, I'll show you how to do it by hand, and then after that, we'll take a look at Desmos. So if you're going to do this problem by hand, what you need to do is basically go ahead and multiply out the left side. Okay, so go ahead and do that. We're going to get just kx squared minus 32x equals negative 4. And then you add the negative 4 to both sides to move it over. So now we have a quadratic equation that is equal to 0. So we can just go ahead and we can basically take the discriminant, b squared minus 4ac, set that greater than 0. That will guarantee that we have two real solutions. So here the b value is the negative 32. A value is just the k. C value is just 4. So basically you go ahead, negative 32 squared is going to be 1024, and then minus 16k is greater than 0. 1024 is greater than 16k. Go ahead and divide this out, and you should get 64 is greater than k, or, in other words, k is less than 64. Now, if k was equal to 64, then this expression would be equal to 0, which means there would be exactly one real solution. So the maximum value of k is not going to be 64, but it's going to be the next integer down, because they tell us in the problem that k is an integer. Therefore, the correct answer that you would submit, the maximum value for k, is 63. Now, let's see how we could do that in Desmos. So what you're going to need to do first is just move everything over so it's equal to 0. Or sorry, so it's, essentially equal to 0 in terms of an equation, but we're going to set it equal to y here to graph it out. So once we have that, we'll just add a slider for k, and essentially we're going to increase the slider. Now I'm going to set the step as 1. Let's set a max of 100. We're just going to keep increasing the slider and seeing, okay, how far do we have to go that we still have two real solutions, i.e. two x-intercepts. So notice here at 63 we do. However, when we go to 64, we only have one real solution. Therefore, the maximum integer value for k, which will guarantee two real solutions, is 63. And that is how you could confirm this or solve this in Desmos. All right, next, let's look at question number 2. Here you're told about a triangle. Note it is not necessarily a right triangle, but you're told that the sine of one angle equals the cosine of another angle, and then you're given expressions for the measures of each of them, and you're asked to find the value of x. So the property that you need here, what allows you to solve this problem, is the fact that the measures of q plus r together have to add up to 90 degrees. And that's because the sine of one is equal to the cosine of the other. And if you think about a right triangle, now again, this is not a right triangle, but if you think about a right triangle, just like this. So like, take angle A up here at the top. The sine would be the opposite over the hypotenuse, okay? This side over this side, BC over AC. Then you take angle C down here. The cosine of it would be the adjacent, which is the same side BC, over the hypotenuse, same side AC. So the sine of A up here equals the cosine of C down here. And what do we know about A and C? Together they add up to 90 degrees. All right, so with that being said, you just take these two expressions and you add them together. You set it equal to 90. Just for a little practice review, let's solve this in Desmos instead of by hand. So you could just type the whole thing. Now we're looking for a vertical line. Where is it? Oh, it's right here at 8. So the correct answer to this problem is going to be 8 for the value of x. Note that if you plug them in, you get 31 degrees. And then for the other one, let's see here, we get 32 plus 27. Why is it not 32? Oh, 59. So we get 31, we get 59, and if you add those two up, they do add up to 90 degrees. So it checks, it works out. All right, question 3. This is a repeat. This first appeared on the May test. So for this problem, you have a circle. You have your center right here, O, it says 0, 0. You have A out here at 1, 0. This is basically a unit circle, it has a radius of 1. And then point B is basically going to be somewhere down here, at this point. 4 over root 97, negative 6 over root 97. Okay, and then we have angle AOB here. And they're told the measures W radians. What's the value of tan W? So the thing is, and I mentioned this in the May video, I won't spend that much time going over it here, but in general, when you have a unit circle question, you just take the point that's on the unit circle, and we know that the sine is equal to the sine of the angle is equal to the y-coordinate value. We know the cosine is equal to the x-coordinate value. Tangent's basically going to be y over x, because sine over cosine. The thing that was a little tricky about this one, though, is the fact that this angle, it's normally, when you're doing that, you're talking about an angle that starts, right here at 0 degrees, and it goes around counterclockwise until, for example, it would end in the 4th quadrant. We're normally not talking about, this small angle here, which is basically, less than 90 degrees or less than pi over 2 radians. But in any case, the fact that the angle is referred to as AOB, meaning starting here and then going this way, seems to indicate that it would be technically a negative degree angle. Therefore, it is just going to be essentially what I just described, that shortcut. It's just going to be negative 6 over root 97 divided by 4 over root 97. The root 97s cancel out. You get negative 6 over 4 or negative 3 over 2. Or you could also give the answer as negative 1.5. And that's what the value of the tangent of this angle here, which has a measure of W radians, is going to be. All right, next, let's look at question 4, top of the next page. This is also a repeat question. It appeared back in 2024. Don't remember the exact month. But basically what you have going on here is you're told about the, note this is the diameter, not the radius, but the diameter of the smaller inside circle is 8 centimeters. Okay, note that means this radius is 4 because diameter is all the way across. You're also told the shaded area, kind of like the area, the donut here, and it wants to know how long is AB. So there's technically two ways you could solve this. First, I will actually show what I think is the quicker, faster, easier way. And then I'll show the second way is actually a longer way, but it's actually the initial method that I thought of. So quicker, faster, easier way is to look at this and say, okay, say this whole thing here is x. Okay, area of the large circle is just going to be pi x squared. Again, this is area of the large. Then when we subtract from that the area of the small, you could say the area of the white circle here, that's going to be pi times 4 squared. All right, and then that's just going to be equal to the shaded area, which is 560 pi. So essentially, the pi's we can just cancel out and get rid of. So we get x squared minus 16 equals 560, or x squared equals 576. Or you can go ahead and square root both sides, and x is going to equal 24. So that's the total length from the center, basically for the radius of the large circle, center to the outside of the large circle. So what's the length of AB? Well, AB is just going to be 24 minus 4, diameter of the small circle. Therefore, AB is 20. That's the correct answer. All right, so this I think is actually the quickest, fastest way to do it. Now I'll show you an alternate way to approach this. Again, this is the second way. This is how I actually did it initially, but I think this is a lot more work, at least in terms of setting it up. So what I actually did initially is I said, okay, let's let A be what we're solving for, bx. Then we know that the area of the large, which is going to be pi times x plus 4 squared, minus the area of the small, which is going to be pi times 4 squared, is equal to the 560 pi. So now what you have to do, again, pi's cancel out. You got minus 16, 560. Here you have to multiply this all out. X squared plus 8x plus 16. Now, you basically get x squared plus 8x minus 560 equals 0. Let's just save a little time, and let's just go to Desmos to solve this instead of doing it by hand. All right, what do we have for our solutions? We have negative 28 and positive 20. Okay, obviously we're only concerned with the positive one, so x is going to equal 20. Same answer we got using the first method, but it looks like it's a little bit more work, a little bit more complicated, but you could just as easily solve it using this approach as well. All right, next up we have a system of linear equations that deals with percentages. Based on what they give you, you're trying to figure out which equation, is correct for this situation. So you have one chemical, it's 1% nitrogen, another one's 5% nitrogen. The total mixture is 500 grams with both chemicals mixed together, and we want the overall concentration level to be 4%. So your two equations, the first one should be obvious. It's just total amount of x plus total amount of y is just going to equal 500 grams. And I guess actually in the question, I'll fix this in the worksheet. In the question, it should specify what x and y stand for. X represents the amount of chemical x, y represents the amount of chemical y. So just starting off, x plus y equals 500 should be the first one. So get rid of this, get rid of that. And then the second equation is basically amount of nitrogen. So that's going to be, 1% of the total amount of chemical X and 5% of the total amount of chemical Y. Together, we want 4% of the 500-gram mixture to be nitrogen, and 0.04 times 500 is just going to work out to be 20. So the correct answer for this one is going to be letter C. All right, next up, here we have a right triangular pyramid. This is a repeat question. This one appeared previously. Again, don't remember the exact month, but it was in 2024. So if you think about pyramid, okay, looks, this is maybe a bad drawing. See if I can get this a little bit better. Okay, there we go. Each edge is 52. Okay, you can see there's 6 total edges. So the total surface area is whatever, some number, root 3. So what's the value of k? All right, so if you just take one face here of an equilateral triangle, 52, 52, 52, you want to find its area, you can split it up. And we know since it's equilateral, this is 60, this is 60. This 60 at the top is split into 30 and 30. So now what happens is, let's get rid of this. This becomes 26 because if you think about special right triangles, 30, 60, 90, the relationship or the ratio between the short leg side across from the 30 down here and the hypotenuse is basically 2 to 1 or 1 to 2 depending on which way you're going. So you divide the hypotenuse by 2 to get this, and then the height is going to be 26 root 3. You multiply the short leg by the square root of 3. So the area of one of these is going to be 1/2 times the base, which is 52, times the height, 26 root 3. So this just becomes 26. Therefore, the whole thing becomes, just make sure I get this correct, should be 676 root 3. So again, that's the area of one of the triangular faces. And there are 4 of them. So you're going to multiply this by 4, and that gives you 2704 root 3. Therefore, k is just going to equal 2704. So that's your answer. Now, you could save some time on this if you know the shortcut formula for the area of an equilateral triangle, which is just s squared root 3 over 4. You could just take 52 square it, root 3 times 4, but now there's 4 faces, so when you multiply by 4, these are just going to cancel out. So notice it's just really 52 squared root 3, and let's see, that should give us the 2704, get rid of that we got using the other approach. Let's just confirm. Yeah, 52 squared, 2704. So that's just an alternate way to think about this. Probably, potentially save a little time if you know the shortcut formula for area of an equilateral triangle. All right, let's go to the top of the next page. Question number 7. Here we have 2 rectangles, basically that are similar. And essentially what you're going to do here is first find the area factor, which is just going to be 1800 divided by 200. Cross out the zeros. 1802 is 9. So that means the area of one is 9 times the area of another. So also it should mention, I guess it does need to mention in the problem technically that the rectangles are similar, so I will add that, I'll correct that on the worksheet as well. That means the scale factor, which is the square root of the area factor, is just going to be 3, i.e. each side in the larger one is 3 times the length of each side in the smaller one. Therefore, the perimeter is going to be 3 times as large for EFGH compared to ABCD as well. So the perimeter of ABCD, the smaller, is just going to be 210 divided by 3, which is just 70. So therefore, that's the correct answer. You find the area factor, you take the square root of that, that's the scale factor, and then the perimeters basically will be related by the scale factor, which in this case is 3. All right, let's look at number 8. This is a repeat question. This has definitely appeared a fair number of times in 2024. So for an absolute value equation to have only one solution, essentially it has to equal 0 once you have the absolute value expression isolated by itself. So notice here, first of all, if you divide by 2, you now have k over 2 on the right, okay, and k over 2 is what they want to find the value of. For this to have only one solution, this right here must equal 0. Therefore, the answer to this question is 0, and technically that's it. Really what happens is, if you, because when you solve an absolute value equation, you're supposed to set up 2 different equations, like one with the positive number on the right side and one with the negative. So if it's any value other than 0, you're going to get 2 answers, you know, because you have x minus 4 equals, say, positive 5, x minus 4 equals negative 5, and you solve each of those, you get 2 numbers. But it's not the case with 0, because 0 is not positive or not negative. So therefore, this k over 2 has to equal 0. That's it. That's the answer. There's really not, not a lot of other work to be done. Okay, question number 9. This is another repeat question. This one deals with the buffalo and like the muscle mass and bone and fat and percentages and everything. And so I'm going to try to work through this one as quickly as possible. And there's actually 2 different methods you could kind of show. So here is, I guess this is what I think is the easiest approach to take. So notice you have this buffalo, right? The whole thing 100%. 63.4% is muscle mass. So if you subtract that away, what you're left with is 36.6, right? So you have 100%, okay, being split into 63.4, which is muscle, and then 36.6, which is bone and fat. And then that 36.6, which is bone and fat, is split up with 52.3% of it being bone and the rest of it being fat. So in other words, just the bone down here is basically 36.6 times, 52%, 0.52, and then the fat is 36.6, and it's just, or sorry, this is 50, this should be 0.523, not just 0.52. All right, and then this should be 1 minus that, okay, which is going to be 0.477. Let's just go to Desmos to confirm, make sure I've got all these values correct so far. Yes, 0.366, 36.6. And now 1 minus 0.523, 0.477. Okay. So essentially, now what you could do is, let's see, we want to find to the nearest tenth of a percentage the fat composition of the overall mass of the buffalo. So technically all you have to do now is just multiply these 2 things together, and that should give us our answer. And there it is, 0.174582. Now, we want to report this as a percentage, so technically it would be 17.4582%, but it says find to the nearest tenth of a percentage, so therefore we would round this to 17.5%. And of course, you don't report the percentage sign as your answer. It's just, 17.5 is what you type in, but that's the correct answer. This is what I think is the fastest, quickest, easiest way to solve this. I will show you another approach, though, which is that you can actually solve for the specific values for, I mean, muscle mass were given, but for bone and for fat, and then you can divide that to find the percentage. It's going to be more work, but I'm going to do it pretty much all in Desmos, and we'll see what we get here. All right, so I know that the muscle mass is 119.5 kilograms, and that is equal to 63.4% of, I'm going to call overall O. Okay, there we go. So that's the overall mass. The overall mass is 188. Okay. Therefore, if we go ahead and we basically take the overall mass and we multiply that by the 0.366, this is the mass, this mass here, 68.985. This is the mass of bone and fat together. Okay? Now, in order to get the mass of bone, what we have to do is we have to take 52, I'm going to call this, that's not going to work. Let's see here. Will this work? No. All right. Whatever. I'm just going to get the bone mass, I'm going to take this and I'm going to multiply it by 0.523. Now, to get the mass of fat, what I need to do is basically I need to, oh, actually I could just do the opposite. I could, or not the opposite, but multiply this instead of by 523, I could do it by the 0.477, which is the percentage of the fat. Again, 1 minus 0.523 basically. So the total mass of fat is this number. And now you could just divide this by the overall mass. And notice I get the same value I got doing it the other way, the 0.1745482. Now you have to multiply it by 100 in order to turn it to percent and round it. But basically, what I'm doing is I'm using this number to calculate the overall body mass first. All right, that was the 188 point whatever it is. 188.4858. That's the overall mass. Then I essentially, I don't take 52.3% of that. I take, so then what I did is I said, okay, I take 36.6% of this because 63.4% is muscle. That means 36.6% is bone and fat. So I took this times 0.366. That gave me the total mass for just bone and fat. And then, and it comes out to like 68.958. And then what I did is I multiplied this by 0.477 to get just the fat mass. And that comes out to something like 32.906. And then I divided that by the overall mass. And that gives me the percentage, the fat composition of the overall mass, which is the same number I got using the first method. It's just more work and more, calculations, but it is an alternate approach you could take. All right, now let's look at the last problem, question number 10. Here you're given the equation of a line, and you're told about another line which is perpendicular to it, and you're told 2 points that this perpendicular line passes through, both of which have a constant in it. What is the value of that constant? All right, so first I'll show you how to do it by hand, and then I'll show you how to do it on the calculator. So this original line has a slope, line J, of 1/4. Therefore, the slope of line M, which is perpendicular to it, is just going to be -4. So now you can just set up the, slope equation. y2 minus y1. So I'm going to do k minus -k. I'm just going to do this minus this. And 0 minus 40. So on the top I get 2k. On the bottom I get -40. Right side I just have -4, or technically -4/1. Cross multiply, 2k equals 160, k equals 80. That is the correct answer. That's what you would fill in. Excuse me. Now, let's see how we could do this in Desmos. So essentially what I'm going to do is, because I have constant here in my points, I am going to enter the values, the x and y coordinates, in separate lists, not in a table. So these are the points, x and x, y and y, and I'm going to do linear regression. I know again the slope is -4. So I go ahead and I solve this, and notice it just gives me k is equal to 80, which is what we're looking for. So this is how you do this entire problem in Desmos, basically using lists for the 2 points. Alright, so I hope you enjoyed this video, basically June 2025 SAT Math problem worksheet number 2. If you did enjoy this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, check out the videos on worksheets number 1 and 3 and 4, once those are posted. If you have any questions or comments, please do leave them, or alternate solution methods as well, please do leave them on the video below. And otherwise, just a reminder, if you're looking to improve your knowledge and use of Desmos to help ace the digital SAT math section, please check out my Ultimate Desmos Guide to Digital SAT Math. It's up to now basically almost 4 hours of tips and tricks and almost 60 practice problems covering all aspects of Desmos, including many advanced use cases of regression.